Hello, welcome to Don Labs. This episode we're just going to give you a quick run through on how to use your multi-function multimeter. Okay, I've just got a cheap multimeter here, nothing special. We're just going to run through a couple of the functions just to give you an idea of what it can do. And so let's just have a look at the dial on the multimeter itself. As you can see on the dial we have our resistance symbol there. We have a number of values of resistances going around the dial. We have HFE. HFE is to do with measuring transistors. We'll get into that in a second. And then further on the dial we have our V for voltage, and this symbol indicates that it's a DC voltage. Then we have a few voltage ranges, and then we go into a V for voltage, but with this symbol is AC voltage. Again, we have a few voltage ranges. Then we have F, which is for capacitance, and we have a few in the range for capacitance. We have an A with this squiggly line again, which is AC, so we have our current AC, and then we have our current DC, and then we have a continuity test. Okay, also as well as the dial here, obviously we have our normal LCD display, the power button. This little section here, as you'll notice, it has a PNP and NPN. Let's just make sure you can see that. So it's got PNP and NPN, so this is for measuring our transistors. And then down at the bottom here we have V for voltage, omega for ohms, and the little l.e.d for continuity test. That will be where your positive lead goes into for the majority of the functions on here, except for current and capacitance. Okay, now this section up here where we measure our transistors, that doesn't actually use the leads, they plug directly into this section. Okay, and the current, which is here and here, that will be using with the red lead either in this one or this one. The common, which is earth, always stays the same. Okay, now as you can see there it says CX, so capacitance will be this one and this one, and it also says milliamps, which is why I said current up here and up here. We'll use this one and this one, unless you go above the maximum current range is 200 milliamps, then you have to use this one, which is 20 amps. I don't recommend measuring anything as high as 20 amps with a cheap multimeter though. Okay, so let's just plug the leads in and we'll take a few readings and see what we can do, and then we'll get into this device over here straight after. So first things first, what we've got it set on to start off with is our continuity test. This is for testing whether two parts of a circuit are connected basically. So I'm going to go ahead and I'm going to plug the negative lead into the common port, the negative port of the multimeter, the positive lead into our voltage, resistance and continuity test port. It has got a warning on my particular multimeter, it should have one on yours as well. It will give you the maximum you should measure with this meter, AC 750 volts and DC 1000 volts, although I wouldn't like to quite go that high with one of these meters, to be honest. So bring the meter in shot, press the power button. As you can see, we're not reading anything, we're reading 1, which is open circuit, and that's because the probes are not touching. Now if we touch them together, we make a circuit, we get an audible beep, we get a light, and we get a 0 on the screen. Now the numbers on the screen is actually the resistance in the circuit. So because we are getting a short circuit, which is the direct connection, it's almost no resistance. Now if we were to use the continuity test to measure a resistor, let's put that on top of the meter so you can see it. We don't get a beep because the resistance is higher than a certain threshold, which is only a few ohms, but what we do get is the resistance on the screen, which can be quite useful because it's basically like getting an auto range on your multimeter. So instead of having to select the value of resistance, it comes up on the screen. Now this will go up to a certain value. Once you get into too high a resistance, let's try this one. We touch our terminals on the legs of the resistor, it's just reading 1, which is error open circuit still. Now basically this is because the value of the resistor is too high to read on there. So That's our continuity tester, and what we can also do with that, which is quite useful sometimes, we can take our LEDs, we can put the positive of the continuity tester onto the anode and the negative on the cathode, and our LED will actually light up. Now this is very low current, low voltage used to test the continuity of the circuit, so it's safe just to quickly test LEDs, just to give you an idea whether your LED is working. Okay, so next, resistance. We have values 200, 2K, which is 2000, 20,000, 200,000, 2M, which is 2 million, 20 million, 200 million. Now, this resistor, looking at the bands on the resistor, we have orange, orange, black on there, so I know that resistor is a 330. We'll go into how to read resistor bands in a different video. So I'm going to set the multimeter to 2K because 200 is too low to read it and 2K is the next lowest number. And it's about right. You're going to get a little bit of variation. The leads aren't exactly perfect either. This resistor was too high to measure. And looking at the bands on this, which is brown, black, green. I think this one's 1 million, I believe. We're going to set this on 2 million, the multimeter, and I'm just going to measure across this again. So let's just get that into focus. Yes, that's just under 1 million. Obviously with the coloured band on the resistor you do get variations in the resistor as well as the variations you're going to get from using a cheap multimeter with poor leads basically. So that's our resistor done there, and obviously if you were to measure just another resistor value here, looking at the bands on this, I believe this one's 100k. So the range is too high, so it's not going to be a very useful measurement for us. So we put that down. Let's put that down to 200k. And you can see 99.4k. So basically you can measure the resistance with the higher range. I can measure that on 20 million. Still get a reading, but it's not going to be as accurate. Okay, so that's enough of resistances. Now we'll go into the HFE setting. So we don't need the leads, we'll put them down. Now HFE, you're going to need to know a couple of things, but you can sort of play it by ear. You're going to need to know what legs are what on your transistor, and you're going to need to know whether it's an NPN or PNP. If you don't, you can just plug it into the meter and hope you get the right way round, but you could possibly damage the component, which is not what you want to do if you're taking a measurement. Now this one, I know it's an NPN, and I know that the legs are EBC, which is emitter base collector. So I'm going to plug the legs in that order as it's written on the multimeter just down here, EBC. Push it into place, and it's going to give me a HFE reading 281, which I can then check on the data sheet. Now if I was to put this in the wrong way, so if I was to put it in this way, so the multimeter is expecting BCE, base collector emitter, you'll see, just get a battery sign and a 1, which is error basically, and that could potentially damage your component. Now I'm going to measure a PNP transistor, exactly the same, but use the PNP holes. It's actually base collector emitter. These holes are a little bit fiddly. If we look at the legs on this transistor, I've salvaged this transistor with reasonably long legs, so it's just making a connection. But I've also salvaged this transistor, and as you can see, the legs are a lot smaller on that one, and the problem is it's all the way in and they're not reaching the connector inside the multimeter. So we can't actually measure this small transistor unless we attach wires to it and put the wires in the holes, which can be a little bit inaccurate. It's not really something you want to do for a quick test either. So that's what we would use this device for, and we'll come to that in a second after we finish going through the meter. So next on the list, voltage. pretty self-explanatory. This is a DC voltage, and the way you connect the multimeter to check for voltage is you put the negative on the negative side of the component you want to test, and the positive on the positive side whilst it's running in the circuit. So the circuit has to have power, i.e. voltage, because that is what you are measuring. So what I can do is I have a little power supply, and I'm just going to bring the terminals of that power supply over to here so we can run a quick test. And it is a positive and a negative. And what I'm actually going to do is I'm going to connect small crocodile clip to the positive, just to make it easier to hold, and the negative I'm just going to go straight on with my hand. And as you can see, that's gone straight off the meter because we've got it set on 200 millivolts. So we obviously know that voltage is higher. I know that voltage is higher, but this is, if you didn't know, then it'd be best off to start off on a slightly higher voltage. So we set it to 2, straight off the meter. We set it to 20, so anything up to 20 volts this will now read. So our power supply is a 5 volt supply. Okay, now you can set that higher. It's on 200 volts. You still get your 5 volts there. It'll change the decimal place in the middle there. Not as accurate if you set it too high. For example, 1000 volts. It's measuring 5 volts. We know it's 5 volts, but for example, if it was 0.5 volts, you might struggle there. Okay, I don't have an AC supply to show you, but the principle is exactly the same. Just be very careful when measuring AC, because the high voltage AC is a lot more dangerous than high voltage DC. Okay, so we're going to skip through the AC part of the voltmeter because we're not going to measure that, and we're going to go on to capacitance. Now capacitance, you're going to have to take your lead out of there and connect it to whatever one it says on your multimeter with the C or the CX or the FCX. Okay, but normally it's the same way you measure current, which is where the milliamp lead would go. And what you're going to do is you're going to take your capacitor without you touching the wires on the capacitor. You want to join your meter as if it was a voltmeter to this capacitor. Now again, I'm going to use crocodile clips. It's not entirely accurate with crocodile clips, but then again, it's a cheap multimeter. It's not entirely accurate anyway. Let's just connect the negative. This is a electrolytic capacitor, so it is poled. You have a negative and a positive, so negative to the negative, positive to the positive. And again, we've set it on 20 nanofarads, which is way too low for this capacitor. If we just have a look at the side, it's a 10 microfarad as denoted by the UF. So we're going to change our multimeter to 20 microfarad, which is the closest we have, and it's given us a reading of 8.9, which is pretty close to the 10 that's on this capacitor. Okay, you can't always read the numbers on the side of the capacitor, hence the reason for using the multimeter, and also to see if the capacitor is actually holding as much as what is stated on the side. Now again, if you're like me, you salvage quite a few components. This is a salvaged capacitor, works perfectly fine. It's still 10 microfarads, the same as the one we were just testing, but very short leads. So again, negative to negative, positive to positive, but as you can see, it's getting very difficult to attach stuff to this. It can be done. You can bend the legs, but you don't want to bend them too much because you're going to end up doing some damage. We've connected it, we're getting a reading. It's not too bad, but it's a bit awkward. So again, this method, not exactly great, and that's what we're going to use our component tester for in a minute. So you can measure capacitance. You've got various values on here, ranging, my particular one, from 200 microfarads, 20 microfarads, 2 microfarads, 200 nanofarads and 20 nanofarads. not exactly the greatest, but again, it's a cheap multimeter. To measure the current is exactly the same port as measuring the capacitance. So for this one, I'm going to take my 5-volt power supply, which I previously tested. I'm going to put that onto a breadboard. I have a 220 ohm resistor on there, which I'm going to swap the leads over and just do a quick test. I'm going to put that on my resistor, and I'm going to get on the screen 218 ohms, so I know 220 ohms, there's a little bit of variation in there. Now I'm going to put my leads back to current measuring position. I'm going to change this to 20 milliamps, and I'm actually going to plug an LED from positive to the resistor, out of the resistor, through a wire into the anode of an LED, out of the cathode into the negative, and my resistor is limiting the current to my LED circuit. The circuit is lighting the LED, and now I want to see the current through the resistor. So what I do is I take my meter, I'm going to take my crocodile clips, which I'm actually going to have to use for my particular meter because I've only got the spike probes, and I'm just going to place these over here out of the way, disconnect the resistor from one end where it joins the positive, and disconnect the positive feed. Now I'm going to go from the positive on my breadboard into the positive of the meter, and it's going to travel through the meter. It's going to come out the negative lead of my meter, and this negative lead is going to attach to the resistor, which is then going back into the LED into ground. My circuit's lit, it's working, and I'm getting a reading on the screen. Always connect your ammeter to measure the current in series with the component that you're testing. In a series circuit, the current's the same around the whole circuit. With a voltmeter, measure in parallel, so you measure across the component, so no need to take stuff apart for the voltmeter. Component tester is a lot simpler to use and very, very useful. With the component tester, all you need to do plug this into your power supply or your battery, whichever you're using. Now I've made this little adapter for this, which I've shown on another video, just to make it easier to plug the components in. For this reason, remember we said we had this transistor, and it was very, very hard to measure this transistor because of the legs. So with this little adapter, we've got a female pin header going into our component tester, and I'm just going to plug that transistor straight into the header, press the button, and we get PNP 123, which is 1, 2, 3, is ECB, emitter, collector, base. So we instantly know what legs are what on the transistor. We have a forward voltage 650 millivolts, and we have the HFE reading just here, which we can compare to the data sheet, see if this transistor is good. But it's not just for seeing if the transistor is good, it's also really useful because we can quickly see if it's working, i.e. by seeing if it's good compared to the data sheet, but also we can tell which legs are which, so we can solder it easily onto our circuit without having to figure out which one's which. So again, with the component tester, let's put a resistor in our female header, plug it straight in, press the button, 998 kilo ohms. Okay, so that's our 1M resistor, and on the screen it says 1 and 3 because we're using pins 1 and 3, or terminals 1 and 3 if you like. And we can do the same thing with our capacitor. We'll wait for that to come off the screen, and what we do, exactly the same with the capacitor. This capacitor was easily checked with our multimeter. This one, however, salvage component, very small legs, very difficult to measure properly. We put that in our female header, press the button, and away the meter goes. Now that's giving us a capacitance of 30, which is actually incorrect. That might be due to the length of wire on here. It's a little bit longer than what I'd like. I'd like to make that a little bit shorter and just recheck that capacitor. So I'm going to take that out and I'm going to change what pins I've plugged that into. And I'm going to press the button again and see if we get a different reading. And there we go, there's the proper reading, 10 microfarads, and it's given us the equivalent series resistance there of 3.1 ohms. Okay, but for measuring capacitance you want the capacitor as close to the meter as possible. That's why it's not very good with the multimeter. With the crocodile clips you can get specific leads that go from the meter to a capacitor, they're a lot shorter. And for this particular component tester, I would like to shorten these wires right down to where the insulation is there. And that's what I might do next actually, and just reduce that right down so that I get a more accurate reading. Now again, I can put the other component that we tested earlier. I can put that straight in, 3 pins. There we go. Base collector emitter, the way that I've plugged it in. PMP, HFE reading, forward voltage 588 millivolts. What I'm going to do is just attach a normal diode just to these screw terminals on the top and just see if it gives a reading on that. So yeah, diode, pins 3 and 1, which is what I've pushed it onto, forward voltage 669 millivolts. Now if I was to attach this diode exactly the same way but in the pin header, we should get the same readings. Yep, diode 3 to 1, 669 millivolts, 10 picofarads. You can actually put 2 diodes in this one, I believe, and it will tell you which way they're connected. So if you get the diodes that are in one package, like the TO220 package, and they've got 3 terminals, you can plug it into this device and it will tell you which diodes are connected to which terminal. I'm just going to try this one more time with the normal LED in there. It really doesn't like this LED. And now we're going to test a different LED and just see what reading we get. And again, I'm just going to nip it up just slightly, not too tight. Now there are other components that are a little bit more difficult to test in your component tester, like the big resistors like this. Very difficult to test them in there without using a lead. So what we could do is we could put one end in like this and tightened up a little bit. You could potentially put a crocodile clip on the other end of it, like so. And then the end of that, I've got a pin on the end of my crocodile clip. We can put that in there. It's not exactly the best way of testing it, but if you had to and you didn't have any other way of testing this resistor, you could do it that way. And we press the button and we get 10.6 ohms, which is reasonably accurate. It's a 10 ohm resistor. We're getting a little bit of resistance in the crocodile clip. I would hazard a guess the crocodile clip's probably given at least 1 ohm of that reading, but you're better off measuring this type of resistor with your multimeter and the probes. So certain things are better off with the multimeter, some things are better off with your component tester. I would personally measure all your transistors with the component tester and all your basic components like the resistors, the multimeter as well. Okay, and that concludes our use of the multimeter and the component tester. Thank you for watching. Don't forget to like and subscribe, and don't blow up.